what are we doing exactly? So we start with our benzene, right? Our benzene, right? And then we are attacking that benzene using our electrophile. Which electrophile? The one we just generated, right? And so this electrophile could attack any one of these bonds. So suppose it attacked this one here, right? Another important thing to know is actually this is wrong, because the arrow should always go from electron rich to electron poor, like that. So when that happens, what will you form? You form a structure that will look like this. So this bond here will break, and then the chlorine could either sit there or sit there, but I'll make it sit there, right? And then when it sits there, it's important to take note that the hydrogen is still there. So if the hydrogen is still there, this part here becomes electron deficient and then gains a positive charge. Okay, our aromatic attack is done. Next step, you need to show resonance. Why are we showing resonance? Because of this structure here, one thing you've seen is this has lost its aromaticity. And then you lose aromaticity whenever the benzene derivative of the benzene structure has lost its planar geometry. So you'll be able to see that this particular portion here is tetrahedral. So the entire molecule is, or the entire compound is not what? Aromatic. It has lost aromaticity. And so it will try to change in configuration in order to restore the aromaticity. So what will it do? So this is what it will do. So the first thing, we draw the exact same structure. Exact same structure with a positive charge there, and the chlorine there, and the hydrogen. And then it will try to restore stability. To try to restore stability. So you could draw them in advance, and then I'll explain how we do it properly. And then our last structure, so you need to draw 4. Like that, yeah. So the first thing is this. You see this structure here, the positive charge is here. So it will try to move the positive charge around. So a simple way to think about it is that positive charge will always skip a corner. So it will move from here all the way to here. But then how does this happen? So this bond here, this pair of electrons here will scooch over and come here. And so there it is, right? And then this one will be exactly where it was. And then this positive charge will skip a corner. It will be here, right? And then this will come there. And so when this comes there, it will be here, and we'll have that there. And then this will skip a corner. We'll have the positive charge there. And then this one is our arrhenium ion. The arrhenium ion. So when drawing the arrhenium ion, you start from where the positive charge started from. It started from here, and then made its way all the way to this corner here, right? It's a positive charge. So that's our arrhenium ion. So having done that, you've done resonance. And so in the last step, what will we do? In the last step, we need to restore our aromaticity. And so to restore aromaticity, we'll use this here. And then we'll restore aromaticity. But then to restore aromaticity, what do you need? You need your conjugate base. So I hope you're able to follow. So just I'll make some space. So I'll call this step restoration. That's our step 4, restoration. So in restoration, what are we doing? We start with the version of benzene that lost aromaticity. So it looked like this. It looked like this, right? And so what do? We're trying to restore aromaticity. This part here is sp3 hybridized. It's tetrahedral. And so we need to restore our aromaticity. And so we do that by using the conjugate base. So we say plus the conjugate base, like this. Right? And so what do we need to know? First thing you need to know is this. You extract this hydrogen, right? But then, of course, the arrow needs to go from electron rich to electron poor, like that. But then you extract this hydrogen without getting the pair of electrons. And so, this actually should be like this. Yeah, this should be like this. It's just I didn't copy it right. And so, one thing you'll be able to see is that this pair of electrons will come here, like that, right? And so, what will you form at the end of the day? This hydrogen and this chlorine, one thing you'll be able to see, or in some books, one thing I've seen them do is this line will come from here, so that you can break the bond and extract the chlorine at the same time. And so you form hydrochloric acid first, because the hydrogen and the chlorine have gone, right? The next thing, what will you form? You form chlorobenzene. So it will look like that. That's the bond that has formed, and then you have your chlorine there, chlorobenzene. And then because this has come out, you now have your catalyst. Isn't that where we came from? Yeah. So you'll be able to see what are your final products: chlorobenzene, chlorobenzene. Your catalyst, hydrochloric acid, hydrochloric acid. Or let me put it here. Yeah, so that's typically how halogenation is done. So the mechanism is the same with bromine. Yeah, so that will mark the end of the video.